My name is Marty Schmidt. I have the pleasure of serving as the Provost of MIT, and on July 1st, I'm going to assume the role of President at my undergraduate alma mater, Rensselaer Polytechnic Institute. I'm very happy to greet you all this morning. I want to start by thanking the co-organizers of this workshop, MIT, RPI, and SUNY, for pulling together such an exciting agenda and for giving me the opportunity to offer some opening remarks. The theme of this workshop, Semiconductor Technology Translation and Hard Tech Startups, is, of course, a very timely theme as we await approval of a much anticipated federal government commitment to strengthen domestic semiconductor production, development, and research. For those of us who have worked in this field for many years, either in academia, industry, or government, this is a particularly important moment, and one which I believe we are all tremendously excited about and eager to help advance this important agenda. But to paraphrase a TV commercial, this is not your father's Oldsmobile. I believe that in order to seize this moment, we need to be prepared to think boldly, act decisively, and be prepared to reinvent our practices and not be encumbered by old models of engagement. This workshop will tackle one area that is ripe for work, and that is the process by which we bring the work of academia to have impact through commercialization. Today, you'll talk about regional ecosystems, a very important point. Transfer of technology is a contact sport. You need to have strength of all stakeholders in order for a region to succeed. This requires collaboration amongst all that are committed to regional strength. Universities must seek opportunities to work together to create a commons that benefits all players. In Boston, we've done that through the creation of joint entities like the Broad Institute of Harvard and MIT, and the Mass Green High Performance Computing Center, the latter bringing together 5 universities to create shared computing infrastructure. We've studied what it takes to build strong regional ecosystems, and without doubt, the most important factor is when universities, community colleges, non-government economic development agencies, and the government work together as unappointed actors to shape the agenda for the regions. You're also going to discuss the perspective of industry, venture investors, universities, and government. Our experience is that all these actors have a role in the commercialization of what we refer to as tough tech or hard tech. We created out of MIT a new entity called the Engine, which is a purpose-built organization to support hard tech startups. And when I mentioned new models of engagement earlier, I often think about a recent startup out of MIT called Commonwealth Fusion Systems, or CFS for short. CFS is committed to demonstrating commercially viable compact fusion reactors. It's hard to imagine a more important thing to work on, and indeed one that could save the planet, dare I say. The work we did to structure the agreements between MIT, CFS, their investors, which included venture capital, large companies, and venture philanthropy, required us to rewrite all the ways in which we do things. And I'm pleased to say that thus far, things are working extremely well. You're talking as well about intellectual property. This is a conversation we have to have, and it should be informed by identifying shared goals. The goal of the university is to ensure that the ideas get put into action, and that path may be by direct transfer to industry or through a startup. We need to make sure all paths are open. Our job is not to squeeze the last % of equity or royalty out of an invention. It is to make sure these agreements motivate all parties to utilize the ideas or make them available to others. As a nonprofit institution, we take a long view towards rewards. That occurs when our PIs and inventors remember the role that we played in helping make an impact and make them successful. Lastly, you're going to talk about shared facilities, foundries, and design tools, all very critical elements, particularly in the field of semiconductors. We all know that when compared to other fields, hard tech takes a long time to commercialize, requires significant capital, and expensive facilities. I believe there are opportunities to address these pain points through the topics and ideas you will discuss in this session. In closing, let me thank you and wish you well. At MIT, we have been delighted to work with many of you to help shape these ideas. And to my colleagues in the Capital Region, I look forward to engaging you much more deeply when I move out there in July. I hope you all have a wonderful workshop today.
Thank you, Provost and President-elect Schmidt. On behalf of my colleagues and workshop organizers from SUNY, RPI, and MIT, I am delighted to welcome you to the workshop on semiconductor technology translation and hard tech startups. My name is Vladimir Bulovic. I'm a professor of electrical engineering at MIT and the founding director of MIT.nano, the new 200,000 square foot shared laboratory facility that aims to redefine hands-on innovation. It takes a village to grow a fledgling idea into a prototype that can then become a product that will hopefully reach millions. That journey from idea to impact for new microelectronics hardware technologies, tough tech as we know it, typically takes over 10 years and a lot of financial support. The inventive idea typically starts in an academic lab, then gets prototyped, probably by a startup, then gets scaled up by the same startup or maybe by an established company. And along the way, there better be financial support from the venture community, intellectual property agreements with university licensing offices, scalable production foundries that the startup can access, agreements of other stakeholders, and finally, the acceptance of the final customers. This complex landscape is navigated by brave startup entrepreneurs whose vision and diligence is the key to the final success. Startups are hence the defining link in the chain of launching the new hard tech ideas, and starting and sustaining more hard tech startups will generate more technology and more new jobs, which will benefit the established industry partners, nurture new industries, and can lead us to the resurgence of US leadership in microelectronics, as well as many other related fields. We all recognize the need for truly disruptive semiconductor technologies, but we cannot redraw the technology roadmap and concomitantly expand the US workforce without a national innovation ecosystem that can help these technologies to mature. So standing up a national program to support this disruptive tech development will ensure the long-term national security and competitiveness. In the first session of the workshop, we will focus on what contributes to a thriving innovation ecosystem and how does one build a system for hard tech startups. We will hear from three distinguished speakers from both established and emerging ecosystems. Through their words and nuggets of wisdom, this session will highlight US regional differences. It will also suggest actions that could elevate regions seeking to expand support for hard tech entrepreneurship. Our first speaker is Professor Fiona Murray. Professor Murray is the Associate Dean of Innovation and Inclusion at the MIT Sloan School of Management, a William Porter Professor of Entrepreneurship, and an Associate of the National Bureau of Economic Research. She's also a Faculty Director of the MIT Legatum Center for Entrepreneurship and Development and the Co-Director of the MIT's Innovation Initiative. Professor Murray serves on the British Prime Minister's Council of Science and Technology and has been awarded the Commander of the British Empire for her service to the innovation and entrepreneurship in the United Kingdom. She's an international expert on the transformation of investment in scientific and technical innovation and into innovation-based entrepreneurship that drives jobs, wealth creation, and regional prosperity. Professor Murray.
Good morning, everybody. My name is Professor Fiona Murray. I'm a professor at the MIT School of Management, and I'm absolutely delighted to be invited by Professor Bulovic to participate in this conference. Now, the role that Professor Bulovic has given to me is to talk about innovation ecosystems, and in particular to talk about the very successful ecosystem that has been created in the Greater Boston area. So I want to take a few minutes to basically give you a sense of why I think that Boston has been so successful and some of the elements that have allowed the Boston ecosystem to be incredibly important in its support of deep tech ventures, particularly ventures in software and semiconductors. So with that, I'm going to share my screen so that I can actually share with you a few slides. And so as I note, my topic today is basically to think about how we build successful innovation ecosystems and what lessons we can really draw from Greater Boston. Now, just to put these ideas into a nutshell, Greater Boston's ecosystem has been profoundly important in supporting deep tech, and it has been able to do that for really three main reasons. The first is strategic focus. Boston has had a very significant focus, both in the life sciences, in clean tech, focusing on things like climate, but also in hardware, often applied to issues of defense and security, but certainly hardware much more broadly. The second element of Greater Boston's success is its system. That is the system of key resources that deep tech founders can turn to and can access in terms of human talent, funding, infrastructure, and sophisticated sources of demand. And the third are really the stakeholders. Boston has growing and important connectivity among some of the key stakeholders. And so it has a purpose community that's been built around some of these priority areas. And so together we see that the strategic focus, the system resources, and the stakeholders are really what allows Greater Boston to be a very powerful ecosystem supporting deep tech broadly. Now, I want to just step back for a moment, as I always do, and really define innovation. It's a quite overused buzzword, but the way I like to think about it is as a process of taking ideas from inception to impact. And I want to clarify that ideas, we mean a match between problems and solutions, but those solutions often grounded in science and technology, but really it's not about solutions on their own, it's actually about solutions that are there to actually support us solving some of our biggest, most important problems and challenges. We want to emphasize impact because we want to encompass more than simply profit, but think about wider mission impact and wider economic advantage. We focus on the process because it lets us highlight the journey and some of those system resources that we need along the journey from what you might think of as lab scale to global scale, and then recognize that the journey engages many, many stakeholders, startup venture founders themselves, but also risk capital providers, corporations, universities, and of course, the government. Now, there are some very unique characteristics that deep tech innovation has in terms of semiconductors, hardware, and beyond. So when we say deep tech, what do we mean? We mean it's deeply grounded in new scientific discoveries or engineering. It has very deep levels of risk that we need if we're going to bring these ideas along from lab scale to global scale, along what you might think of as the classic technology readiness levels. And it requires deep pools of capital and expertise to support rapid growth, de-risking, and learning. And so together, these factors mean that deep tech, whether it is in software or hardware, but in particular in semiconductors and hardware, really does require significant support to create the sort of economic advantage and impact over that typically 10-year journey that we need. And so whether we're thinking about photonics or quantum computing, hardware that we need in new satellite systems, regardless of the type and flavor of deep tech, it's often this support that we need that's actually so critical to success. Now, we can take many lessons from economies who've really built significant advantage in deep tech. And through the MIT REAP program, I've had the opportunity to work with regions all over the world, some of which are particularly skilled at doing this. And I would think of Singapore and Israel as two places that we can learn from, but also obviously around the United States. And I'll talk specifically about Boston, but there's clearly much we can also learn from Silicon Valley, from Austin, and elsewhere. So the first thing is that the places that have been most successful in supporting deep tech ventures and supporting advantage and innovation more broadly have really created what we would call innovation ecosystems. These are geographically bounded locations, often having nothing to do with political boundaries. Greater Boston being an interesting example. It's actually, the ecosystem is probably narrower than the state of Massachusetts, but it's broader than either Cambridge, Boston, or Somerville alone. These ecosystems tend to have a high concentration of the resources that we know are so important to support these innovation-driven enterprises, these kinds of ventures. They're characterized by dense social networks that connect people together and support the sharing of ideas and that sort of exchange of ideas and resources. And these ecosystems ultimately create a unique culture and identity that can be really profoundly important to their longevity and their effectiveness. Now, ecosystems that support deep tech as I say, whether that be Israel or Singapore, Greater Boston, Silicon Valley, do have these three key characteristics. They have the strategic focus on a key set of emerging technologies and sectors. They tend to have very deep system resources that support the growth, the risk-taking and learning along each one of those technology readiness levels and along that journey that we know often takes at least 10 years when we're doing something extremely new right out there on the innovation horizon. And they're also characterized by stakeholders who are aligned in these key areas, who have expertise, who exchange resources, and who manage risk. And when these three things come together, they tend to be mutually reinforcing. They create opportunities, they help support success, and they certainly inspire cultural change and this kind of notion that we have a culture that supports us taking the really significant but smart risk associated with deep technology and all its challenges. So let me just dig in particularly to this question of the system resources that seem to underpin our support for deep tech ventures and that tend to be highly concentrated in successful innovation ecosystems. We like to think of them as having sort of four elements: human capital, funding, infrastructure, and demand. So think about human capital. We're talking about places in the world that are able to attract, train, and retain experts who have insights into the critical challenges and the sorts of expertise that we need across all of those technology readiness levels. So we need human capital that's not just grounded in the basic science, but also has some of the engineering, the scale-up expertise, and so on, but also some of that managerial expertise that is needed to actually understand how you match this very deep tech, hard tech semiconductors to particular problem sets. The second key resource is funding. We're talking about a range of capital sources from grants to equity for these sorts of ventures. And that funding needs to be aligned to some of the particular challenges that we face in deep tech, especially the longer time horizons and some of the risk profile. While we see risk capital and venture capital in particular being spread more evenly across the world than perhaps it was about a decade ago, it's also the case that venture capital for deep tech, with its more significant risk, its technical risk, and its long time horizons, continues to be highly specialized and very concentrated in places like Greater Boston. The third is infrastructure. We know that, again, when we're trying to do something in hard tech, that's hardware, that's in semiconductors, we actually need test beds. We need what Professor Bulovic would call foundries, where we can explore our new solutions, where we can actually, for lower cost, do rapid experimentation. We need shared facilities and infrastructure, and we need access to higher TRL production facilities that let us test things out at commercial scale. That's something that Boston has been growing, but is extremely important in our ability to build these companies successfully. And then fourth, we need demand, right? We need customers. So we need early signals of key problem areas, whether they're sent by government or large corporations. And we need that demand in the form of potential contracts, which allows us to experiment through early stage procurement. That's extremely important to deep tech ventures who actually need signals of success early in their life cycle. And so it really is places where we can gather these resources, the human capital, the funding, the infrastructure, and demand that are likely to be incredibly successful. Secondly, we need places which have key stakeholder interactions. We like to think of there being 5 key stakeholders in these ecosystems: entrepreneurs and their teams who are driven to build these kinds of startups around key national priorities, risk capital providers who have enough technical depth and expertise to invest in some of these sectors with strong partnerships and processes to enable foreign investment and to really be effective in supporting the whole life cycle of these companies. We need university research and administrators who understand these priorities, who understand some of the opportunities, and who are willing to share their resources. We need corporations who have some of the strategic assets and who have access to supply chains. And then we need government to serve as a lead customer and funder, who are also willing to provide technical infrastructure and things like that. So these are the key stakeholders that we need at the table, and it's their interactions that really strengthen our deep tech ventures. And so what of Greater Boston? What is it about Greater Boston, in particular the Kendall Square ecosystem, that really does support the density of deep tech ventures that we see around us when we step outside of MIT's campus? And we might ask the question, how did this really come about? Well, it's come about over a number of years and over a number of phases. And probably the easiest place for us to start is just after World War II, when Greater Boston's innovation ecosystem took off. It was in 1955 that Businessweek ran an article entitled "New England Highway Upsets Old Way of Life." Route 128 was becoming what they called the magic semicircle of Massachusetts. And ultimately, Route 128 became synonymous as a technology region. At the same time, we had this massive rise in university-based funding, particularly from DoD, building on all the funding that had come to MIT and elsewhere in Massachusetts as part of the war effort. And we also saw increasing government funding for basic science, again, through the National Science Foundation, the endless frontier that we're talking about again today. And so by 1957, there were almost 100 companies employing over 17,000 tech workers on 128. By the time we get to 1973, there are over 1,200 companies. And yet around that time, around 1973, 75, we also see Boston starting to actually be written out of innovation history as a loser to Silicon Valley. And Annalise Saxenian, when she was at MIT writing her thesis, talked about culture and competition in Silicon Valley in 128. And you can see in this graph the sort of separation in terms of the number of high-tech jobs as Silicon Valley really takes off and Boston starts to dwindle. Dwindles because I think these stakeholders were not coming together and the kind of resources, those system resources, were not really being put behind some of the growing companies. 128 was just that bit distant from the universities that were so core to their creation in the first place. And yet at the same time, still in deep tech, Boston's leading biotech ecosystem emerges. Again, you'll see we've taken from 1975, and you'll see in that pink line the takeoff of Boston's life science ecosystem. And later, Boston taking off in climate tech. So another form of deep tech. So both areas that are very mission driven, very deep technology. And so we see Boston kind of coming out of the ashes in many ways. And these ecosystems emerging much more closely around Kendall Square and much more deeply connected to the universities. And so the core of Boston's success is an ecosystem with the system resources and the stakeholders supporting deep tech ventures. It's a place where we have the kind of human capital, funding, infrastructure, and demand that will actually support deep tech ventures across a range of mission challenge areas, whether that be in health security, climate security, or more classic defense and security. We're seeing the investments in human capital, developments of different kinds of funding sources, and in particular, that all-important infrastructure that lets us actually serve as test beds and test out our new solutions to do more rapid experimentation. And then there's access to higher TRL production facilities at commercial scale being absolutely essential, as are those very early demand signals from government. Boston's success is also grounded in the fact that our ecosystem actually talks to one another. Like right here in Kendall Square, you can walk into entrepreneurs, risk capital providers, the university faculty and students, government and corporations in this very tight proximity. And it is those resources and stakeholder engagement that I think have been profoundly important to Boston's success. And so the question I think we want to ask really is, what else must we do in our innovation ecosystems to support these kinds of deep tech ventures and support this kind of economic advantage, particularly in hardware and in semiconductors? I think we need to ask ourselves, do we have the right strategic focus on the key set or subset of technologies and sectors? Have we created the kind of level of system resources that's so essential? And are the stakeholders aligned and talking to one another? I think this today's conversation is an important part of that stakeholder engagement, both for the greater Boston ecosystem, but also for the connected ecosystems across the United States and beyond. So with that, I look forward to our discussion. Thank you very much.
Thank you very much, Professor Murray. That was truly inspirational. I very much look forward to asking you questions during our panel. Our second speaker for this morning is Dr. Robert Metcalfe. After a decade at University of Texas at Austin, Bob Metcalfe recently retired from this position as a professor of innovation at the Cockrell School of Engineering. Dr. Metcalfe was the founding director of UT Austin's Texas Innovation Center, as well as UT Austin's Murchison Fellow of Free Enterprise and Professor of Entrepreneurship at UT Austin's Metcalfe School of Business. Visionary, driven by delivering impact, Dr. Metcalfe was an internet pioneer beginning in 1970, starting at MIT, then Harvard, Xerox Palo Alto Research Center, Stanford's, and 3Com. Many of us know him as the inventor of the Ethernet. He is a life trustee emeritus of MIT and a member of the National Academy of Engineering, and has over the years accumulated incredible amount of wisdom in thinking through how to stand up a very effective innovation ecosystem. Bob.
Hi, my name is Bob Metcalfe. In 1972, a gaggle of us MIT grads moved from Cambridge to Palo Alto, and we took the Massachusetts startup ecosystem with us. We started calling it Silicon Valley. Now, maybe it wasn't exactly 1972 when Silicon Valley moved from Massachusetts 128 to California 101, but you have to admit our timing was pretty good. Why did Silicon Valley move west? Because the East was adopting the wrong law of computing. The East was guided by Grosch's law, 1953, which says bigger computers are better. The West was guided by Moore's law, 1965, which says smaller computers are better. IBM's Herb Grosch proved wrong. He had punch cards and dumb terminals and time sharing and vertical integration. Intel's Gordon Moore proved right. He had semiconductors, microprocessors, software, and a startup ecosystem. The real founders of Silicon Valley were Stanford professors, Fred Terman and William Shockley. Terman joined the faculty of Stanford in 1925, Shockley in 1956. Both Terman and Shockley arrived in Palo Alto with MIT PhDs. Terman's advisor at MIT had been none other than Professor Vannevar Bush, creator of the National Science Foundation. Shockley, after getting his PhD at MIT and moving to Bell Labs, shared the Nobel Prize for semiconductors and the transistor. Shockley then moved west to be with his ailing mother in their hometown of all places, Palo Alto. There in 1955, Terman helped found Shockley's Semiconductor Lab in the Stanford Industrial Park, which Terman had founded in 1951. Shockley's going home to his ailing mother may be the real reason Silicon Valley took root around Palo Alto and not around Murray Hill or Route 128 or Austin or either of the Menlo Parks. The slow growth of startup ecosystems is pretty random. Shockley's was the first Silicon Valley startup. He was a technical genius and an excellent recruiter, but a terrible CEO. He recruited 8 of the best semiconductor geniuses to staff his startup. A year later, what's called the traitorous 8 all quit and began the proliferation of Silicon Valley semiconductor startups that continues to this day. When discussing why Silicon Valley surrounds Palo Alto, I always bring up the weather. Never far from sunny and 72 degrees Fahrenheit. They say Seattle is rainy, Austin has hot summers, Boston has cold winters, Silicon Valley has the warm California sun. My reason for moving to California was the Beach Boys. They sang about surfing safaris. It wasn't until after I moved to Palo Alto that I learned the Pacific Ocean is an hour away, below 60 degrees Fahrenheit, with dangerous rip currents and great white sharks. In 1972, I joined the Xerox Palo Alto Research Center, which is still located in what is now called the Stanford Research Park, created by Terman. Stanford's park is 700 acres and 10 million square feet of office and lab space, major infrastructure for a startup ecosystem. I think of Park as one of Stanford's labs. I left Xerox PARC in 1979 to found my own Silicon Valley startup, 3Com Corporation. A week after I incorporated 3Com, in June of '79, I got a call from a guy named Steve with a company named Apple in a city named Cupertino. When Steve learned that I had just founded 3Com and would not be joining Apple, he didn't get mad. He helped me all through the 1980s. Steve was 10 years younger than me. I wondered if it was wise to let a dropout kid run a startup. Steve is famous for being one of the most successful CEOs of all time. But note, Steve founded Apple in 1976, but he did not become CEO until 1996. Steve believed in what's called adult supervision from the very beginning. I got that from Steve. This is a good attitude for a startup ecosystem. 3Com's first few founders were my fraternity brothers from MIT. Most of the rest came from HP. After bootstrapping for a couple of years, I sold a third of 3Com in 1981 for $1.1 million, a third. Intel founder Bob Noyce and HP CEO John Young were two of my angel investors. They helped me recruit my adult supervision, Bill Krause, from HP in 1981. We IPO'd with Morgan Stanley in 1984. After raising venture capital, going public, and growing independently for almost 40 years, 3Com was merged back into HP in 2010. During the internet bubble, 3Com's revenue hit $5.7 billion, and it was briefly valued at an inflation-adjusted $52 billion, of which I didn't even get half. How did we know back in 1979 that the internet would fly? Because we had a time machine. We had built, 1972 to 1978, a nationwide internet inside of Xerox, our time machine, including personal computers, Ethernets, file servers, routers, laser printers, etc. When we left Xerox to grow the internet, we knew exactly what to do. Startup ecosystems need time machines, which is one reason research universities are so important. The San Francisco and Massachusetts Bay areas are now heavily networked. Proximity promotes connectivity, which promotes collaboration. Venture capitalist John Doerr famously said that he wouldn't invest in a startup more than an hour's drive from his office in Menlo Park. Denizens of Kendall Square must have a similar rule, only it's about not walking more than 100 yards. Intel founder Bob Noyce, RIP, and I co-chaired a Silicon Valley fundraising campaign for MIT. Bob was an enthusiastic PhD alum of MIT. At a meeting to assess the giving potential of alums and set MIT's fundraising campaign goal, I asked if MIT alums were worth what? A total of $1 billion. Bob Noyce smiled kindly and said, much more than that. I had not noticed that Bob was by then himself worth several $1 billion. He was fondly called the mayor of Silicon Valley. Speaking of money, startup ecosystems feed on venture capital. The father of venture capitalism is said to be Harvard Business School professor General George Dorio. He formed the first modern venture capital firm, American Research Development Corporation, with MIT President Carl Compton in 1946. ARDC famously invested in an MIT spin-out in Maynard called Digital Equipment Corporation, investing $70K and returning $38 million. I named my model of startup ecosystems after Dorio. This model oversimplifies the startup ecosystems I've observed over the decades along 128, along Interstate 101, in Kendall Square, along Interstate 280, around the University of Cambridge, in Austin, and elsewhere. The Dorio startup ecosystem has seven all-important species. It is important that all seven and some others are prospering in your ecosystem, and that they are enthusiastically connected, cooperating, and competing. And here's the seven species. First, funding agencies. ARPA, DOD, DOE, NSF, NIH. The second species are research professors who get money from the funding agencies. MIT's Bob Langer is by far the best example. Number three is graduating students joining these startups, and I do not recommend students drop out of college for startups. 4, scaling entrepreneurs, people graduating from previous startups. 5, venture capitalists, founders, family, friends, fools, angels, VCs, PEs. and 6 strategic partners, incumbents trading their brand and scale for innovation, and finally 7 early adopters. God bless customers who risk buying from startups. Those are the 7 species of the Doreo startup ecosystem model. Startup ecosystems are all the rage these days. There are many good books, websites, Wikipedia entries, conferences, classes, and so on. I suggest Brad Feld. He's an MIT Sloan graduate, software entrepreneur who moved to another startup ecosystem, Boulder, Colorado, and he turned VC. He founded Techstars, a renowned startup incubator. Brad's excellent book is Startup Communities. Start there, it's hard to go wrong. One way you can get wrong is to confuse startups with small businesses. There's a lot of confusing government data on entrepreneurship that includes both startups and small businesses. Now, sure, startups begin small, but that's just a phase they're going through. Restaurants, salons, retail stores, and the trades are nothing like semiconductor startups, nothing like the species of the Doreo startup ecosystem. So in my experience, you want your startup CFO to be IPO ready, not your brother-in-law. There are 2 kinds of startup that you should not confuse: website startups and tough technology startups. In recent years, I've concluded that the world's most important problems will not be solved by yet another website. On the other hand, tough technology is tough. Let me end by sharing the most important new fact about the human condition. Thanks to telegraph, telephone, radio, TV, internet, and smart mobile phones, 6 billion, or 75% of us 8 billion humans, are suddenly on the internet this year. We are overwhelmed with connectivity. While freedom and prosperity have been greatly enhanced by the internet, it has had its pathologies, which we work on one by one. The first pathology of the internet was porn, and then advertising, and then spam, radicalization, polarization, hate speech, and now the current pathology, fake news. We eventually subdue these with our latest chips. The internet turned 50 in 2019, and it's almost as if we built the internet for COVID-19. The pandemic is fading, and we can soon get back to normal. Will we get back to normal? COVID-19 is having impact on the evolution of startup ecosystems. We will soon, I hope, forget masks. But what about Zoom? People are still using Zoom to avoid COVID. Or are they? My hunch is that people now fear COVID less than they enjoy Zoom. Here we are on Zoom right this second. My hunch is that there are many more people attending this workshop than would have if we had ever been here in person, if we had to be here in person. COVID-19 has provided the activation energy to get us over the hump on the use of internet video for learning and employment. We'll not be going back. Going forward, we'll be enjoying the benefits of collaboration video. Let's shorten collaboration video to COVID for short. How will COVID change our startup ecosystems? Seems to me that where we learn and work is changing. The proximity, connectivity, collaboration advantages of living in Silicon Valley or Kendall Square will fade. Even if, thanks to Zoom, we can all commute from Aspen, we still need access to our instruments, to our fabs. Seems clear that just as internet web startups blossomed with cloud computing, the semiconductor startups will blossom with highly connected cloud instruments and cloud fabs. One of the most important features of a high-performance startup ecosystem is co-opetition. Participants, including incumbents, can cooperate to create research consortia, share resources, and set standards together, all the while competing fiercely. Co-opetition can lead to platforms upon which killer apps are built and unicorns roam. Now, it is often debated whether Stanford or MIT has had the most impactful startups. MIT wins this debate hands down, especially when it is pointed out that MIT's highest impact startup is Stanford. Thank you.
Well, Bob, thank you very much for that. Certainly appreciate your comments in many different aspects of them. And I very much look forward to the panel that we're about to have. But before we can reach the panel, we have one more speaker, David Broecker. Currently serves as a Chief Innovation and Collaboration Officer for Purdue Research Foundation. In this role, he is responsible for advancing strategic innovation initiatives, targeting corporate partners and key stakeholders. As an entrepreneur, Broecker is the founder and CEO of Zorion Medical, a leading medical device company focused on developing and commercializing fully absorbable technology utilizing biometals. Prior to joining Purdue, Broecker was the founding president and CEO of the Indiana Biosciences Research Institute in Indianapolis, an independent, nonprofit research organization dedicated to discovery, science, and applied research. As both an intrapreneur and entrepreneur, Broecker has developed a full appreciation of the ecosystems needed to support startup activity, and he's certainly building one in West Lafayette, Indiana. David, please take over.
Thank you, Vlad, and good morning to everyone. It's a pleasure to be here, and I must confess up front, I'm not an electrical or computer engineer, as Vlad mentioned. I've spent my life in biotech and biopharmaceutical medtech, and I've been more of a beneficiary from a company level, both large and medium-sized companies, as well as startups, of being in a variety of highly innovative communities and ecosystems, including Boston, the Bay Area, and in Europe, in Germany, and in Ireland in particular. And so it's a pleasure today because sharing some of the lessons that I've learned along the way as being kind of a part of these ecosystems is very exciting for me. So what I'd like to do is start with a definition and an example of what we're building at Purdue, talk about some of the critical success factors. Unfortunately, my fellow panelists have covered many of these, so I'm not going to go into too much detail on these, maybe highlight 3 or 4. And I know that some of the follow-on sessions are going to touch upon these as well. And like Bob, I've got a couple ideas in terms of recommended reading, and I really do want to get to the discussion as fast as we can. So when I look at innovation and ecosystems, this has been highlighted before. Innovation is really the execution to coming up with a new solution to a problem that creates value in the mind of the customer. And value, I think the word that's been used previously is impact. Value does not necessarily have to be monetary. It's impact in the mind of the customer or the person that's going to use the solution to that problem. In my job, as Vlad mentioned, at Purdue, it's really to engage strategic partners in terms of understanding what their biggest problems are. So this is a place we start by asking them, what keeps you up at night? What are your biggest problems? And having them articulate that is very important to then figuring out how we can partner and collaborate with them. Ecosystem, Bob touched upon this. It's not, and Fiona as well, it's not necessarily just geographic, but it really is a networked community of people, places, institutions that work together to achieve a shared purpose. And that shared purpose is very important. It provides focus to the ecosystem. And so, I've had the good fortune in the last 5 or 6 years since leaving, a big company work to probably work on the creation of 3 ecosystems. One was the Indiana Biosciences Research Institute, which Vlad mentioned, which was an applied research institute founded by some of the leading companies here in Indiana. What made that interesting is that each was unique and complemented one another from a life science perspective. I would also say that I was tasked with leading the COVID initiative at Purdue to protect the campus. And many of the lessons of how do you build an innovative ecosystem were brought to bear in bringing back 35,000 students in 117 days and keeping them going through campus or going through the semester without interruption. But the one I'd really like to talk about today is what we're building at Purdue now. And so this is a bird's eye view of a new development that's occurring. And what we're doing is we're creating what you'll hear here in a second is our Lab to Life platform. This is a bird's eye view of Purdue University. The campus proper is sort of on the top and right-hand side of this picture. But you see in the colored areas over 400 acres of private development that's now occurring on campus. And when it's built out over the next 10 years, it's going to lead to over $1 billion worth of investment. And when some of us started to look at this, we started to think about, wait a second, we were learning from other so-called connected communities or smart city initiatives. What's the potential here to really use this as a platform for innovation? And when you started to add up the number of people that were going to be in the district here, it was going to approximate about 10 to 15,000 people, residents, employers, innovators that were going to be in this community. And you put that beside the 50,000 or so students and faculty at Purdue, and you quickly can come up with a number of about 75,000. And that is in a greater area, metropolitan area of Lafayette, West Lafayette, about 250,000 people. So when we saw this, we said, wait a second, this could really be an interesting platform. The thing that made this also unique is the scale in terms of both size and people. The other thing was that there was no infrastructure. Infrastructure has been mentioned. So if you flew over this at night with satellite, it looked like North Korea, completely dark. So we had the opportunity really to bring into this district through edge data centers, pre-planned fiber infrastructure backbone, assets that come up out of the ground, connecting to multiple radios, the ability to access all kinds of different spectrum, et cetera. We pre-planned it and we built it just alongside the master plan. And the other thing that makes it really, really important is this is all governed by the Purdue Research Foundation. So somebody mentioned the mayor of Silicon Valley. Well, you're looking at the mayor of the Discovery Park District. And when you look at this, this is what, a lot of my colleagues in the Purdue Research Foundation are architects and property developers and things like that. So they look at all these pretty architectural pictures. This is what we saw, right? You take away the walls, you take away the ceilings, you take away the roofs, and you look at how people are going to live, work, and play in this community. And it truly is starting to bear fruit in terms of what this picture it looks like in campus. When I first showed this about 2.5 years ago, you'll see in the middle a little robot there. And people were like, really? And I said, and yes. And sure enough, 6 months later, we had delivery robots now delivering coffee and pizza and things like that across campus. I think people now see drones here. And you saw on that previous slide that we're connected. Purdue has the second busiest airport in the state of Indiana. And so we're in the process of bringing that onto the platform as well, and not thinking about just two-dimensional mobility, but three-dimensional mobility. So this picture that I've shown probably in the last 2-3 years is really starting to capture people's imagination. So what we did was we invited a group of complementary technology companies. Most startups have an advisory board. And what we did is we created a technology advisory board of AT&T, Intel, Cisco, Dell, these kinds of companies. And we asked them not to invest per se in the infrastructure up front, because we wanted this to be a neutral playing ground and open for all kinds of innovation. We said, look, we can take care of the infrastructure investment. What we want is we want your ideas around innovation and how we could develop a really center for advanced research in terms of networks and use cases. So that's essentially now what we've created is this Lab to Life platform. So it's a lab literally that expands 400 acres, will ultimately encompass 10,000 people, plus the students and faculty at the university. We're looking at, as I mentioned, infrastructure and how to deploy advanced networks, not in a lab, but truly in a community. Our partners are very, very excited about this because it provides the opportunity to really look at interoperability, opportunities, and challenges. In addition, we're looking at certain applications based on some of the strengths of our different colleges and areas of focus in terms of agriculture and manufacturing, mobility, et cetera. So it's a very, very exciting opportunity, and we're very open to collaborating with additional companies. So when I take a step back and I think about sort of the critical success factors, and like I said, I identified 9. One is shared vision and focus. That's been talked about. Leadership to make it happen. Stakeholders, capital. Those are really sort of the what and why of getting something launched and put together. What I'd like to maybe spend a couple minutes on is just the who, where, and how, by focusing really on the talent, the partners, sense of place, the assets, and then the ability really to, in true sense of innovation and startups, how do you go from 0 to 1? And then beyond that, in our opportunity at Purdue and the Discovery Park Lab Live, 10 to X. So I'm going to skip to, and we're going to make this presentation available. But on the talent side, not only Fiona touched upon this, talent, it goes both ways. We want people to come to Discovery Park and the Lab to Life platform. So this is a magnet for outside talent, innovators, entrepreneurs, companies. But it also being based right next to a leading research institution like Purdue, it's a magnet to access new talent. And I think that's a very, very important component of innovation ecosystems. Purdue trains more engineers than MIT, Stanford, and UC Berkeley combined. So we have a big talent pool to draw from. It was touched upon earlier, mix is critical. It's not just all one size fits all. You do need a mix of researchers, entrepreneurs, and innovators. And trying to understand the difference is really what you need. You need to understand what drives these individuals and play to their strengths. I've seen a lot of times where researchers try to be entrepreneurs and it doesn't work. So you really need to understand what drives the individual. In terms of partners and collaborators, these have been mentioned as well. I would just highlight the last point there in terms of connection to other ecosystems. Once we've stood up several of the places that I've mentioned before that I've had a good fortune of launching, I really have also tried to connect to other ecosystems, Boston, Silicon Valley, other places, really based on what our focus has been and trying to expand the shared sense of purpose amongst our collaborators. Sense of place is also very, very important. Where do you go, right? Particularly for these people that are coming in from the outside or companies that want to engage. We talk a lot about the front door at Purdue and where do people come if they're a company. Most people know where to go if they're there for a football game. Most seniors in high school know where to go to get the campus tour. But if you're a company or a startup or an innovator, where do you go? And trying to make it easy for these people is very, very important. Who are the navigators that sort of help these people navigate the ecosystem and find what they need? Obviously, you need hangouts for collisions. People talk about that there's a lot of serendipity in terms of invention and innovation. And I would also say that, in terms of creating a sense of place, I would think about destination as sort of the key here, not just about placemaking, but really about destination. And then finally, we've talked a little bit about infrastructure. You need to create a playground and the kids will come. We want to create the coolest place to be, and the coolest kids will end up coming there and playing on the playground and creating the games that are going to create value for the future. It needs to be complementary and accessible. We have over 100 core labs at Purdue. And so making the ones that are open for sharing is takes time, but it's a key asset. I know that in my own startup career, I've tried to avail myself of those things that are available, but it requires staffing and training to make happen. And then finally, this notion of technology readiness levels and going from idea to impact. A lot of times what we try to target is sort of that middle area. technology readiness levels 3 to 6. And that helps you get, moving in the right direction. But in the Discovery Park District, what we're finding is it's not equally important. It's not just the technology innovation, but reinventing the business associated with these platforms, particularly when it comes to rolling out new use cases involving new networks. And you definitely need scale and focus and commercial viability. Otherwise, people aren't going to come. So that's really going from 0 to 1 to 10 to X. And our partners that we brought into the district really see the opportunity to cater to the 70 or 75,000 citizens or residents that are going to be part of the Discovery Park District. And then finally, just some recommended reading. 0 to 1, I think most people are familiar with that book. That's a great book by Peter Thiel. Smartest Places on Earth is another interesting one. This is really looking at sort of the or off the radar sort of emerging places that are happening. It was written by Antoine van Achmal. He was an investment banker and is the one that came up with the term emerging markets. So he made his fame back in the 70s by investing in emerging startup companies. Very good book. And then Strategic Doing, again, the sense of execution and making things happen. So those would be 3 books that I would recommend. So Vlad, I'll turn it back to you at this point for the discussion. Thank you.
David, thank you. That is exceptional insights in an emerging ecosystem. Dear audience, if you have questions for the panelists, please type them in the chat. We will make sure that we pass along the ones we receive and ask the panelists to indeed respond. As the moderator, I have the privilege of actually starting us off. Fiona, Bob, and David, thank you very much for presenting to us a holistic view of thinking about what an ecosystem of supporting a startup and growing an idea really takes. It is very hard in each of your 10 to 15 minutes of presentation to indeed capture a journey that will take 10 years. However, you have placed in our minds a set of challenges, a set of opportunities, and through the talks, you have also exemplified what has been done in the times past. Hopefully what's coming in the times to come will not be that different, at least the insights of what we have received as a knowledge from time that we have seen will indeed inform us how to build the next set of amazing startups. What does tell me is that the ecosystems do vary across the world. And indeed, if you count how many effective places on the planet there are to launch an idea and grow it, how many of those are around? And maybe I can ask Professor Murray, just as a background of how many places can I go to launch my startup? And I would find myself right now saying, oh, here's a working ecosystem where I can easily transition that idea into a product that millions can use.
So as always, Professor Bulovic, we can rely on you to ask the hardest and do it, making it sound so easy. So if I understand you right, how many ecosystems do we think there are in the world where I could easily take my idea to impact?
Yes.
So I think it would be fair to say that if my idea was in the sort of consumer, so I'm solving a problem for consumers, and my solution is largely grounded in software, I actually think there are a lot of places, and there are many more places than there used to be. So I think we used to imagine that America and a variety of places in the US were the perfect place to do that. I think it would be fair to say, looking at some of the most recent unicorns, that you could do that extremely effectively sitting in Cairo, within sight of the Great Pyramids. You could do it sitting in Lagos. There are a variety of places in East Asia. So I think, and all over Europe, in London and Berlin, in Paris, in Station F, etc. So I think if it's in software, we would dozens and dozens of places, and places that are actually even more exciting than doing that in the US today. I think the more the technology becomes deep tech, as I would define it, the more it becomes focused on hardware and really requiring of complex stage of technology readiness, the more we need new foundries. The smaller where we're likely to be able to do that. And so I think the deeper it gets, the smaller the number of places where we can probably be effective.
Bob and David, in your experience, actually translating hard technology into a brand new idea? Is it pharmaceutical or is it semiconductor? As Fiona points out, there are very few places you can really turn to. So what does it really mean for a startup to have a great semiconductor idea if the journey from that idea to that idea being broadly adapted becomes dramatically limited simply by the ecosystem that might be able to support that kind of growth of that kind of idea?
Well, when Mark Zuckerberg was dropping out of Harvard with his Facebook thingy, he got some advice. And the advice was, if your consumer software company, if that's what you're going to do, you need to move immediately to Palo Alto. And he did. And it worked because he plunked right down into an ecosystem that was completely complementary. So, for example, if you were innovating in energy, I would say go to Houston, because Houston will be solved in, energy will be solved in Houston. It's just so obvious. Semiconductors, well, there's Boston and there's Silicon Valley, and I bet you Purdue has some semiconductors. What, David, do you?
That's what I was going to say, Vlad, is the world is becoming digitized, right? And Purdue just celebrated their 152nd anniversary as a land-grant university. And over that time, we've seen innovation from the industrial age, right? And now we're moving clearly into the digital age. And everybody needs to figure out, how do I digitize my innovation strategy? And everybody needs a chip to make that happen, right? I mean, that's why we see all these supply chain issues emerging, and why there's now bottlenecks in cars, in energy, in retail, and all these different places. And so I think that you're going to see the core of what's historically been Boston and Palo Alto, but I think you're going to see some emerging areas like Bob started to point to: energy in Houston, agriculture in the Midwest, centered hopefully around a place like Purdue, automotive manufacturing probably also sort of centered in the Midwest, and then you start to think about the ancillary things and the additional intervention. There's a lot of converging innovation that's occurring. And so I think those places that really facilitate that convergence, I think will emerge as, as the future places. We work a lot with some of the Silicon Valley companies, but it's very hard to get like a use case implemented in Palo Alto for a mobility project, right? Well, come to Purdue, where you got acres and miles where you're not going to hit anybody but a cow, right? If you want to do mobility projects, do them out here, right? So, and that's this notion of extending the footprint. So I think you're still going to see the traditional places where people have gone, but I think you're going to see some emerging places based on the use cases that emerge because of the chips.
I think the difference is going to be that in the past we haven't had the internet, and now we do. And so that dynamic, the connectivities you were talking about are going to be easier to create. So there'll be more fluidity in where resources can be located, don't you think?
Well, so I will just again remind the audience, if you'd like to submit a question, use the Q&A feature at the bottom of your Zoom window. And
a breakthrough that we need in connectivity is how to turn off the mute button. So David's mute button is on, and how do we signal to him that he needs to turn his?
I'm paying attention. I'm only going to chime in when I need.
So let's make a chip that turns off the mute button automatically. What do you think?
I think you just blink and it happens. But listen, Bob, the question that I have for you actually is someone who has lived through multitudes of innovation ecosystem and saw them grow, either thanks to your own inventions or inventions of others. Over the last decade, you spent your time at Austin. When you arrived in Austin, the bustling of the Austin innovation ecosystem was present, but wasn't as dominant as you would see it right now. What changed? What caused the growth of the Austin ecosystem?
I went there 11 years ago, and I promised to help Austin become a better Silicon Valley. And there was considerable resistance because there's a culture there of wanting to stay weird, keep Austin weird. And I kept telling people being weird and being a successful innovation hub are not the same thing. But a big problem with us back 11 years ago is we only had one venture capital firm, Austin Ventures. And if Austin approved, you did well, and if Austin didn't approve, you didn't do well, and it was a bad situation. But then Austin Ventures fell apart, and so we've been invaded over the last 11 years by many venture capital, and that has solved that problem. So now we have syndication capability, the ability to have in-town VCs syndicating with Silicon Valley and Boston VCs. As I'm fond of telling people, VCs know how to fly. And there's non-stops from all those places to Austin. So the syndication, I think that would be the number one improvement, has been in the syndication of funding.
Mm-hmm. Well, so that is VCs and themselves, right, is the key element of providing for the startups. And we will indeed hear more about it in the panels that follow from different stakeholders. If you're gonna try to design from scratch, and money is no object, a program that would assist launch of more hard tech startups, the ones that deep tech, as Professor Murray calls them, the ones that are able to go ahead and deliver the next set of hard tech ideas, what would we do? What are the elements of that new program that the nation can maybe support in order to make the launches even more effective than what we've seen in the times past? And since Professor Murray started us with deep tech, and of course, this is a hard question, the appropriate one for me would be to pass it to Professor Murray to see if we can maybe get some insight.
Sure, thank you. So what would I do? I mean, I think we actually have quite a lot of the elements of these programs already floating about, you know, all over. I think in the iCore program, I mean, there are all sorts of interesting elements of that. I think at the moment it's a bit fragmented, and I do sometimes think that we end up in a sort of sea of buzzwords, that everybody has to have their sort of version of an entrepreneurial kind of playbook, as opposed to perhaps understanding some of the really fundamental principles that to anybody who thinks hard about science and technology knows that, you know, the fundamental sort of tenet of science is you have an experiment and you run a hypothesis, and that in fact trying to commercialize something in any sort of deep tech and with hardware and so on is also all about kind of resolving uncertainty. I think what we do is basically focus on people who are coming to the end of their PhDs and postdocs and kind of give them the opportunity to really explore the potential of their idea and some of the ideas around them. I would start to build teams around those people, but I would also get the faculty advisors involved. So I think at the moment we sort of either talk to faculty or we talk to students and we're in the room together. So I actually think that we ought to think about faculty and students together so that they purposefully build their ideas and their companies towards particular problems. I think we need to do that in a way that puts problems in front of people as opposed to sort of solutions looking for a home, because I think that can be really powerful as a focusing device. And the other thing that is perhaps less important in the US, but is certainly important everywhere else in the world, and that is that many investors and venture capitalists don't have any technical background. So if you talk to the average VC in Europe, they'll typically have a degree in history. And that is a fantastic education, and they are very erudite and knowledgeable, but they're not particularly embedded in the networks of the scientific and technical community, nor necessarily kind of have a framework for asking the questions about the sort of technical risk that they're undertaking. And so I would also, especially if we were doing this outside of the US, that I'd want to educate people on the other side of the table, the venture capitalists, to understand much more about technology or get more technologists onto the other side of the table.
Wow. So indeed, the actual journey of preparing a startup does involve a variety of stakeholders, including the professor and indeed the entrepreneur student who will actually grow there. David, you mentioned creating a playground and kids will come as a way of highlighting the opportunity. You also mentioned complementary and accessible being the key. So identifying a particular ecosystem opportunity that is indeed differentiatable and consequently will attract kids to the playground, as you say. Is that enough? Or do we have a curated need to prepare those entrepreneurs in ways that Professor Murray has mentioned?
Oh, absolutely. You know, you need, they need to understand what the rules of the game they're about ready to play are. and you know, you don't want them to hurt themselves either, right? And so you know, I think it's very important. It becomes a magnet. It obviously, you know, if there's a unique asset or a unique capability or a unique sort of thing that the innovator and entrepreneurs need in order to advance their idea through, you know, again, execute, you know, that will attract people, right? But you also need the rest of the ecosystem around them, right? They need to be trained. They need to understand, you know, what's ahead of them. It's not easy, right? They need to engage with customers to really understand and validate their problem. As Fiona mentioned, you know, don't just come up with a solution and then search for the problem afterwards. So they need to be able to talk to, you know, other stakeholders, customers. They need to be trained. You know, we have boot camps that we put our students and even faculty through if they have an interest. As I mentioned before, it's very important to understand what drives these people because being an entrepreneur is not easy. And everybody thinks, oh, I'll just be Mark Zuckerberg, or, you know, I'll just be Steve Jobs. And it doesn't happen, right? It just doesn't happen, as Bob pointed out. And so I think you need more than just the playground. But the playground, you know, you definitely go to those places where the playground exists and has some of the coolest toys to play with.
I was once told by a good colleague and a VC, actually, in his own right, that in order to get trained to actually be an entrepreneur, you need to prove that you can make first 3 sales. After that, you have gotten your stripes and you can march forward with some amount of confidence.
And get thrown out of a VC office 100 times
Yes.
and find that one, right, that will invest.
Absolutely. One of the premises of spaces like MIT.nano is that for us to actually launch the next set of ideas, we need a lot of expensive tools. And those tools already exist at places like universities, where you can step in and use them for a few $100 an hour and not invest millions of dollars needed to actually get access to tools like that. I have my answer to what I think is needed for this, to make a chip like the one right behind me. Certainly tools like that. How transformational, especially for the field of semiconductors, would be to have a national access to semiconductor processing tools that could be shared and consequently maintained on behalf of the startups or the broader technical community who's investigating new technical ideas. And how rational is to link this to universities, places that already have hungry talent. As I often say, every year MIT fires 1,000 amazing people by graduating them, and these people are looking for jobs. So is that link, intimate link, by inviting startups to spend time at university facilities, is that maybe a solution to enable us to have a more effective translation of ideas and also dramatically reduce cost of access and cost of having the access to the tools that could make that next set of high-tech technologies?
What happened to the one we already had? Wasn't there a time when there was a facility, a fast turnaround semiconductor facility in the ARPA community, and you could submit your designs and get your chips back? What happened to that? Is that gone? Because that's what we need. That's what you're talking about.
In a way I am, except there you would be using standard processes. You'd be using yesterday's technology as opposed to inventing hafnium oxide that will make your silicon with silicon dioxide faster, or at least more energy efficient, or strained silicon wafers that you would not be able to put in a foundry until you convince someone after a decade. Hence, you would like to make your prototype somewhere that is much more flexible, much more willing to take on your idea, train you how to use the tools, and try out those ideas. I guess that's what I'm thinking. And I'm thinking that in some ways, universities are simply the place to give you the chance to try out stuff. And that happens to be in many ways what is novel, transformative, Shockley Semiconductor or Fairchild Semiconductor companies are indeed pursuing.
So I was a VC for 10 years. And a bunch of times I was asked to fund the purchase of a scanning electron microscope. And I would always say, gee, I've already bought 23 of those and they're all in Kendall Square. Can you find one to borrow? And they always said, no, no, we can't possibly borrow. We have to have our own SEM because, and then there's a bunch of reasons. So are you suggesting that you're going to have a scanning electron microscope and let anybody use it?
That happens to be the way that places like Purdue's Nano Center, MIT's Nano Center,
So-
Michigan's Nano Center
So-
happen to operate.
So Bob, I'll put on my startup hat. So Vlad mentioned my medical device startup. There's, I think, 4 or 5 scanning electron microscopes at Purdue. They're not used 24/7. My program director we've gone to the center director. He's been trained, and essentially, he can schedule time, and we have to pay a small fee in order to use that. But that's exactly what we're talking about, right? Is the ability to access those kinds of things.
Those are toys for the kids.
Exactly.
Let me
Just
switch
say,
it up.
I
Yeah, no,
think-
please.
I think it's obviously, as somebody who, whenever I have visitors who want to understand some of the magic of MIT, and particularly the magic today in where bringing them to MIT Nano, I think the logic behind it is actually incredibly important. The idea that you amortize the costs of these very expensive individual investments across lots of different projects, across lots of different startups. I think what's also really important is actually the role of the technicians, these people who work on project after project, who are in a way the repository of some of that knowledge, who can help actually move individual projects along and say, actually, people tried that, don't try that, go down this path. There's something important about the machines and the individuals who are the technicians around them. And you build this very powerful community, which is a foundation upon which you can then innovate instead of having to start from the beginning every single time. And I think that's a really key piece of the magic.
I can't but tremendously agree with you, Fiona. The domain experts, as we think of them, are indeed the carriers of experiences of many in a particular domain. Stitch that knowledge with another knowledge of what you want to do to advance, and you can much more rapidly move things forward. And again, a shared resource like a shared facility kind of provides you access to that. Now, I was going to switch just briefly in the last couple of minutes and touch upon a simple question of intellectual property that we'll have a whole panel about. Is there any nuggets of wisdom that one can point to? Is intellectual property, as you see it, significant in the advancement of startups?
This is a chronic problem, which even MIT and Stanford have not solved. But I think part of the problem is we give the TLO, the licensing offices, mixed messages. We tell them we want them to advance the impact of our technologies on the world. And oh, by the way, we want to improve our endowment. And so they're caught between being fiduciaries of a huge amount of wealth that they want to convert for the endowment and being people who want to encourage the proliferation of technology. And they're just caught in between and therefore widely hated. And it's... So fix that problem. And I think the way to fix it is the way I just heard in your introductory remarks, which is the emphasis should be on maximizing impact, not in boosting the endowment.
Agree. And again, being creative. I think to Bob's point, it seems like there's a one size fits all mindset when it comes to IP, and companies are willing to do certain things. They will prepay, for example. Purdue has some corporate partners that we get into that part of the discussion about IP, and they say, look, we'll make it really easy. We'll prepay all of this. And again, to your point, Bob, it's like I think it's going to be then you get arguing into this thing. Guess what? When the probability of technical success is less than 5% on some of this stuff, and I'm speaking specifically about things like life science and biotech investments. Why haggle, right? Why haggle? Time is of the essence. Let's get this thing moving. And so, let's be creative. And I would rather, be successful with 100 things than haggle over the 100 things and let 99 not move forward, right?
Well, in Silicon Valley, one of the expressions is slow magic is not magic, or your way of saying it, time is of the essence. And so one of the problems with TLOs, even if they end up with the right answer eventually, they take a year to do it. And that's not the right time scale for a startup.
Wow. You opened many questions, and the rest of the workshop will hopefully address many of them. Indeed, through the talks, David, Bob, Fiona, you outlined the sets of stakeholders that need to participate in the innovation ecosystem.